All right, so you have, whoopsies, completed the lab on polygons and you found out the cool rules. So we want to determine the sums of the interior angles of a convex dodecagon, a 12-sided figure. Show your work. There's a whole bunch of different ways to do this. One, now it's going to be terrible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay. That's what happens when I try and draw a 12-sided figure. That's going to take a while. If I could draw it, you could just go and count out your triangles. Okay. But from doing the lab, I know that there are 12 sides. There are 10 triangles. And if there are 10 triangles, each one of those is 180 degrees each. So that's going to be 1,800 degrees. And if I could draw, again, that 12-sided figure, I'd be good. So easiest, you take your sides, subtract 2, that gives you the triangles, times 180, and that'll give you your sum. But the handy dandy textbook actually, stop with my paper, I'm sorry, uses a formula for it. And it's right there. So the sum, S is the sum of the interior angles, and N is the number of sides. So let's redo it. So S is equal to 180. Oh, you know what? I'm going to do this right. We start with my formula. And there were 12 sides, minus 2. So we got 1,800 degrees there, 1,800 degrees there. Perfect either way. Don't care on an assignment or something like that. What I would ask is, if you use a formula, good. If you do it, set my paper down. If you do it this way, just make sure you're showing me the 12 sides, 10 triangles, and whatever, so I can see some work, so it's not just you're guessing some random number, right? Because if you do that and you get it wrong, I can't give you anything. If you're at least showing me this, even if there's a mistake in there somewhere, I know it's like, okay, well, they just forgot how to subtract 2 off of 12 and they got 9 out of it, or, you know, it's just a math error. It's not a theory error. I'm not sure how to just what the difference is between them. Okay. If a convex polygon is a regular polygon, you can also calculate the size of each interior angle. Okay, so what's a regular polygon? All the sides and all angles are equal. How many interior angles would a regular dodecagon have? Okay, again, this would be simpler if I could draw a 12-sided figure. But here's one way to do it. There is a 4-sided figure, which I can draw. So 4 sides equals 4 angles. If I draw a handy dandy pentagon, 5 sides, 5 angles. And just to make sure, six angles. All right, so this is a process of inductive reasoning. We did a bunch of examples, so it seems reasonable that if we had a 12-sided figure, there would be 12 interior angles. So if we have 12 interior angles and a grand sum of 1,800, you would just go 1,800 degrees divided by 12. There's my interior angles. I don't know. My brain says 160, but that doesn't make any sense. Divide by 12. Oh, 150. And there we go. So you got to keep this straight. When you're doing these questions, the number of sides is equal to the number of interior angles. The number of sides minus 2 is equal to your number of triangles. And that is the end of the video.